Alright, this is number 25 on page 280. It's a radical equation. I have the variable y under two different radicals. So I'm going to need to isolate each radical term and first, and then, square both sides of the equation because these are both square roots. So I have to isolate them one at a time. So I pick one to isolate first, and I decided to take this one because I always go for the more complex one that I'm going to isolate first. So I'm going to leave that on the left, and I'm going to subtract the square root of y from both sides. Okay, now I'm going to square both sides of the equation to get this y plus 5 out from under the radical, because this is a square root. So wrap and square, wrap and square. So both sides are raised to the second power. When I do that, when I square the square root of y plus 5, the y plus 5 comes out on the left. On the right, this means 5 minus the square root of y times 5 minus the square root of y. So I always get the first term squared minus 2 times this, so 2 times the product of those two. So 2 times 5 times square root of y is 10 root y, plus the last term squared. So when I square the square root of y, I get y. Okay, so starting to clean this up and simplify, I have a 1y on both sides, so I'm going to subtract y from both sides, and then I have 5 equals 25 minus 10 root y. So now I'm going to subtract 25 from both sides. Now I'll have a negative 20 on the left equals negative 10 times the square root of y. And then I can divide both sides by negative 10, and I'll have 2 equals the square root of y. And once I had isolated the first one, then my goal was to isolate this square root of y. So I've done that now, and so now I can once again raise both sides to the second power. So wrap and raise, wrap and raise. So I have 2 squared, which is 4, is equal to y. So I do have to check that in the original equation. So the square root of 4 plus the square root of 4 plus 5 equals 5. So this is a 2 plus the square root of 9 is a 3 equals 5. And indeed, positive 5 equals positive 5. So that works, and my solution to this equation is a positive 4. And that's it.